morning. I'm Alessia Cafaro, a pharmacist researcher at Giannina Gazzini Hospital, the most important pediatric hospital in northern Italy. And today I will discuss on the biochemical diagnosis of DADA2 using liquid chromatography tandem mass spectrometry. But first of all, I would like to thank the DADA2 Foundation for the invitation. I'm so sorry that I cannot be there in presence, but it's really a pleasure to be here. So let's start. First of all, an overview of the ADA reaction. Inosine is produced from adenosine by ADA, and hypoxanthine is produced from inosine by PMP. There are two isoforms of ADA, ADA1 and ADA2, and so to measure only ADA2 activity, we need EHNA, which is a ADA1 inhibitor. Our method is based on liquid chromatography, tandem mass spectrometry, LC-MS, and on dried plasma spot. Liquid chromatography tandem mass spectrometry is considered nowadays the gold standard technology for the measurement of small molecules like inosine, adenosine, and hypoxanthine. And liquid chromatography is a separation technique based on a liquid phase, a mobile phase, which is a liquid, in which the samples are dissolved. And so the mobile phase with the sample will pass through the chromatographic column, and basing on the chemical and physical characteristic of the analytes, the separation of the analytes can be achieved. And the mass spectrometer allow the measurement of an analyte after its ionization. We use triple quadruple mass spectrometer. Dried plasma spot, DPS, is a microsampling device which allow the shipment at room temperature of the samples, so we can easily receive sample from other center by mail. And the plasma should be obtained from peripheral blood collected in tubes containing EDTA by centrifugation. So plasma must be separated from whole blood and then spotted into the filter card paper, which is the neonatal screening card, and dried at room temperature for 2 hours. We measure ADA2 activity by measuring the inosine produced in the unit of time. So we use EHNA as the ADA1 inhibitor, and then we add to the sample adenosine, which is the substrate, and we measure inosine produced in the unit of time. Here you can see the calibration curve of inosine, which cover a wide range of concentrations. As inosine, adenosine, and hypoxanthine have similar chemical structure, we developed a LC-MS method which allowed us to separate the free molecules, the free analytes by chromatography to obtain an accurate result. So here you can see the free chromatographic peaks and the respective MS transitions. After we developed the method, we had to study the reaction kinetics, and we studied the inosine produced by samples obtained from one DADA2 patient, so a patient with a known ADA2 deficiency, and 3 healthy subjects. We use different concentration of EHNA and adenosine until we found the best combination, which allowed us to distinguish the activity in the patient and in the healthy subjects, which was EHNA and adenosine 2 millimolar. Then we clinically validated our method by testing ADA2 activity in samples obtained from 18 DADA2 patients, 4 carriers, and 44 healthy controls. You can find the results of our method in our paper published in 2021 on Molecule Journal. From May 2021, we performed 355 ADA2 tests. And here you can see the box plots for the three groups, which are the subjects with a normal ADA2 activity, the DADA2 patients, and the carriers. We performed the tests on 293 healthy subjects, 36 DADA2 patients, and 26 carriers. The mean activity has MU/mL was 1.35 in healthy subjects, 0.22 in carriers, and 0.02 in DADA2 patients. So our method allows us to distinguish the activity in these three groups. In future, we would like to develop a method based on high resolution mass spectrometry and Papers-Frye-MS, but mainly we would like to improve the use of microsampling devices. In particular, we would like to try to use microsampling devices which allow the home sampling and the separation of plasma from whole blood without the need of centrifugation, and so the need of a laboratory. And it would be important to receive samples from patients all around Italy and all around the world. You can get in contact with me if you want to send us samples to perform ADA2 tests, or if you need any information. This is my email. And in conclusion, I would like to thank all the clinicians and the researchers involved in this project, in particular Dr. Gattorno, Dr. Roberta Caorsi, Dr. Stefano Volpi, and Dr. Giuliana Cangemi, but also all my researcher colleagues, so Sebastiano Barco, Federica Pigliasco, Francesca Schena, Federica Penco, and thank you all for your attention.